Hello, it's Mr. Sarisa, and today we'll be talking about finding the equation of a plane. Now, this is something that's not in your book, but I thought it would be fun to do, and I'll probably put it on the test. So we'll talk about it in class, but I think it's something that everybody can do. So I'll give you worksheets and you'll practice. Okay, so first of all, a plane is going to be on the 3D space model, so we'll have an X, and Y, and a Z when we're doing this. Now, a lot of times it's hard to envision, so remember the plane can go in any direction, in two directions for infinity. So I can only draw it so well here, but so you'll have some sort of plane going through. And then in order to find the equation of a plane, we need 3 points. And so we have 3 points on the graph, and I will call them for now just A, B, and C. And then from these 3 points, we'll form a vector. So a vector for AB, a vector for C. So let me just call those V and U vectors. From these two vectors, if we found the cross product, then we can find a third vector that's orthogonal to both of those, and I'll have that as N. And then finally, in order to find the equation of the plane, I'll have to find some other point, and I'll call that X. And that point X will form another vector, and if I take the dot product between that new vector and vector N, that will give us the equation of the point. So this X is just, that's where our variables come from, our X, Y, and Z. The other points, we know exactly what they are. So I know I made that tiny, but that's because I want it out of the way. So let's come up with our 3 points, and then we'll get started. So A, let's have A be the number 2, 2, 2. B will be 3, 1, 1. And then finally C will be 6, negative 4, negative 6. So we start with those 3 points on the plane, and then we find our vectors. So our first vector is going to be a B vector, just to remind you. And so we just do 3 minus 2, 1 minus 2, and 1 minus 2. So our V vector ends up just being 1, negative 1, negative 1. And then we have to find AC, so that's going to be our W vector. And then our W vector will be 6 minus 2. It'll be negative 4 minus 2. And then finally negative 6 minus 2. Oops. Didn't mean that comma. And then so the U vector, or the W vector, I guess I switched it to W, will end up being 4, negative 6, and negative 8. And so we need to find the cross product of those two vectors in order to find this new vector N. That will be the cross product of V and W. Alright, so we can set those up, and I'm just actually going to do it this way, where we do the I vector. And so we'll have negative 1 there, negative 6, negative 8, and oops, we'll have the J vector. So we subtract the J vector, and that will be 1, negative 1, 4, and negative 8. So if you want to do this another way that you've been practicing, that's fine. I'm just showing you a new way of doing the same thing, of doing the cross products. And then finally we're going to do the K vector, and that K vector will be 1, negative 1, and then 4, negative 6. Okay, and then find the determinants of those. And so I'm doing 8 minus the 6, and that's our I. and then minus negative 8 minus negative 4, so negative 8 plus 4. That's our j, and then finally we'll do negative 6, negative 6 minus negative 4, so we're going to do plus 4 again for our k. And so our n vector will be 2i minus a negative 4, so plus 4, j, and then plus a negative 2, or minus 2k. Alright, so that is our n vector. That's the one that's orthogonal to the whole plane. Okay, and so what we need is this point x, which is just x, y, z. That's, again, where our variables come from. We're going to take the vector x minus, a, and find the dot product of that with n. Okay, so first we have to do all the x minus a's. So that means x minus 2 and y minus 2 and z minus 2, because a is 2, 2, 2, and have that as a dot product with 2, 4, negative 2. And so the dot product will be 2 times x minus 2 plus 4 times y minus 2 plus negative 2 times z minus 2. Distribute all of the numbers that you can, so 2x minus 4 plus 4y minus 8 minus 2z plus 4, and that will equal 0, because we're setting equal to 0 because we know if the two vectors are orthogonal to each other, their dot product will equal 0. And then I'll simplify. So 2x plus 4y minus 2z, and for the constants we just have negative 4 and a positive 4. They'll cancel, and that will leave a negative 8 equaling 0. And that's going to be your final equation of a plane. You could also set that 2x plus 4y minus 2z equal to 8, and you'll get the same answer. But there's your equation of a plane. Thank you. I hope that helps.